we're going to have to do a few things. First, I'm going to pack this geo that we've created. So this polyfill here, I'm going to pack it. And the reason I'm doing that is because I want the centroid, the middle part of this object, the single point. And so if I view this, and now this is packed, and so then I can display as centroid, which is not displaying as centroid. Don't quite know why, but that's fine, because now I'm just going to do an add. And if I add this here, you can now see there's a point, and then if I go to points, I can do delete geometry but keep the points. So then now this whole object just gives me this one center point. So then what I want to do is I want to copy a bunch of points onto this point, and you'll see why in a little bit. So what I'm going to do is I'm going to do a copy. And so this node is really great for just taking a thing and making a whole bunch of it without you having to duplicate it anywhere. It just duplicates it for you. So right now I want like 14 things. And so you can't really see because they're all on top of each other. You could do a transform here. If we were to view this and then I were to translate it, it does that sort of thing, which is very useful in certain situations, but for us not right now. So we're not going to do that, but we're going to have those points. And so then I also want to make sure that this point, right now it's at the centroid, I want to bring it up to the surface of this water bowl, because we're going to make our spinning wind for the top of it. So if I just click on this transform, I'll translate it up to about 0.22. So then now that's a pretty good spot. It's not the exact height of it, but it doesn't need to be exact. So after that, what we're going to do is we're going to create we're going to make a point wrangle so we can manipulate p-scale. And p-scale is just the scale of the point, and if you copy something onto that point, then that object inherits the scale of that point. So first off, we are just going to do a thing that if you've ever seen any of my tutorials, you're going to see me do this a lot. I've done it a billion times. I'm getting pretty good at typing it. So fit01 rand ptnum min max. Alright, so what this is doing is it's just giving us a random value using the point number as a seed. And then here I'm just saying I want a parameter that is the minimum and the maximum of what this point size can be. So then if we hit this, creates our min and max. So first I'm going to do 0.15 and then 0.745. Seems like good numbers. So what I can do now is I can create a circle. I'm going to create a polywire, or sorry, a polyframe. I'm going to do a copy to points. So we're going to copy a bunch of circles onto those 14 points that we created. So if I drag this like this, it's not quite what we need, but it's getting there. So first, this circle, if we look at that, what we want to do is we want to create a polygon instead so that it has points and it's not a NURB. So we want to up these divisions. We're going to up it to 50. You can see them there. And then we want to make sure that archetype is open. So you can see that we have our circles here, but they're not facing in the correct direction. And this is where things are going to get a little interesting. There's plenty of ways to get this done. I'm just going to show you a quick way that I've found to get this to work correctly. So what I'm just going to do is, so when you copy things onto points, they're aligned to the normal of that point. If this doesn't have a normal, it's just going to default to what its original position was. But what I can do is I can say the normal, so normal.y, if I make it 1, then you can see things are facing upward. what's good about this is that I can actually randomize the direction that these are facing, so that some are facing up and some are facing down. To the naked eye, it's not going to look pretty much different at all, but this will be good for us to create different directions of wind. So what I've done here is I've created a polyframe, and then what I want to do is tangent. I don't need a normal name here, I just want the tangent of the normal to be the normal. And so what I can do here is if we look at this, we can see that we are creating a vector along these curves that are going around. The problem is we don't want everything to be moving exactly in the same direction. And there's plenty of ways to change the direction per curve, but I found one way that's just really simple and quick. Is so I can just say at n.y equals, and then we're going to do another fit, so we're going to do a random function at ptnum, and then we're going to multiply it by just a random seed because we might not get exactly what we want at first. So we can change it up a bit, so I can just do seed, close that out. And so just to make sure that these are all between a negative and positive number, I'm just going to do -3 and 3. It could be any number really. It's just going to change the length of the normal, and that doesn't matter for us. We just need to change the direction. So now, if I've done that, I can change the seed, and you can see that if I change the seed, sometimes some of the circles flip. And the reason that's happening is because some of the normals, if we look at this, some are facing up, some are facing down. So that's just a real simple way of flipping things around without having to deal with rotations. You can just change it on the normal itself. And so I found a good seed is just 0.123. Whoop. Man, I'm screwing this up. Okay, cool. So now that we have these going in random directions, what we're going to want to do is we're going to want to resample them. We need more points. And since these have different sizes, we want these to vary up in a uniform way, because if they all have, I'll just show you. So if I make this maximum segments, you can see that these have very tight points, and then these have much more distance between, and we want them all to have uniform distance between the points. So we can't use maximum segments, we're going to use maximum segment length. So I'm going to make this 0.02, and now we have an even distance between these points, and we have a lot of points. So next we're going to want to vary up the shape of these, not a whole lot, just so that they aren't perfect circles. So I'm going to create a point VOP. I find that it's a lot easier to create noise in a point VOP than it is in a wrangle. It's one of the only things I really use VOPs for these days, but people have a lot of different ways of working, so if you like working in VOPs, more power to you. So we're just going to make real simple noise, so just do add. We're going to take the point position that we have, and then we're going to add turbulence to it. Going to make sure that it's 3D noise. Turn it to simplex. And then we are going to, there we go, we're going to promote these parameters. We can see here that it's getting a little wacky. So what I'm going to do is I'm going to change the frequency to something like I'm going to do 3.3. That's what I've found to be good. Obviously the amplitude is way too high. So we got to take it way down. We're going to take it down to just this. So it's varying it up, but not a whole lot. And then what we want to do is we want this to undulate over time. So what we can easily do to make it do that is just in the Y offset, so the noise is going to be moving upward. And if we do at time, and then I'm just going to multiply it by 0.75, so it's going to undulate slower. So now if I just kind of drag through this, if I set the time to be frame correct, then yeah, I think that's a good undulation. So next what we want to do is we want to create a poly wire. So this is going to give us geometry. It's definitely too thick. So I'm going to change the wire radius to 0.02. That's much better. And then divisions, I always crank this up to 10. So it gives us actual circles instead of the square type stuff that it creates automatically. So what we can do now with this is that we can create a volume, and you'll see what I mean here. So what I can do is I can do points from volume, attach this here, and then we need a lot of points here, and since we're working at a smaller scale, we're gonna have to change the point separation to something that's much smaller. So I found that 0.005 gives us a lot of points, but not too many. It's really easy to bomb your box by cranking the point separation to something that'll give you a billion points. So you always have to be careful, and you want to slowly reduce it. Right now I've already put the time in. I know that 0.005 is the way to go. So now I'm going to change the jitter scale so it's not just a perfect grid. I will just pump it to 10 because why not? Alright, so now that we have these points, what we can do is an attrib transfer. And I want to transfer just the normals. So if I look at this now, there are a bunch of points with the normals exactly how I want them to be. So I'll just do a thing that I've done in many, many tutorials. So bear with me if you've seen this before. But this is how I like to create velocity fields. So what I can do is I'm going to do at n equals lerp, so linear interpolation, normal, and then I'm going to do point. So I'm going to get the point value of, in the second input, n pt num, and then I'm going to create a bias. So right now I don't have anything there, so this won't do anything. But what I'm going to do is an attrib randomize. So what I can do is I can say, well, you all have normals, but I want to actually randomize the normals completely. So I can do attrib name is now affecting the normal. In distribution, I'm going to create inside sphere, which gives a really good random position in a full 360 degrees of a sphere. So if I look at this now, you can see that these normals are real random. We aren't going to use them straight up, but we're going to use it to affect the normals that we have here. So now if I create this bias, you can see that, whoop, now they aren't all going perfectly in the same direction. It is randomizing it a bit. And so I found that a bias of 0.3 is pretty good for what we need. So now that we have that, what we want to do is we are going to do at n times equals, and then here we go, going to do fit01 rand pt num min max. Do it all the time. So if we create this, it defaults to 0. I found that a minimum of 1 and a maximum of 3 is what we want here. And then in case we wanted to, we could mult it down. So we could do at n times equals mult just to globally turn it down. And then we're just going to say that velocity at v equals the normal, Because as I've said in other tutorials, I don't like working with velocity. Let me just change the molt. I'm going to make the molt something like 0.085 is what I've found is good, because otherwise it's just way too much. So I've found, just as a quick heads up, if you use velocity, it just looks way different, and velocity is trailing, so it's going to be going in the opposite direction of the direction that you want to be pushing. So you can see all the normals are going in one way, and then the velocity is going in the opposite. I find it hard to see and hard to comprehend. I mean, I obviously know what it's doing, but it's much more visually correct to me to see the velocity in the normal going in the direction that I want it to go, not the way that it's coming from, if that makes sense. So I always just create normals and then convert the normal to the velocity. So with that, then all we need to do is do a volume rasterize attributes. So this is going to create volumes out of any attribute that you have. And the attribute that we have right now is V. And we can't really see much there, but what we need to do is we need to change the voxel size to 0.05. We're going to turn the particle scale way down, 0.05. And there's really not much that we can see right here, but it's there. It's just, you can't really see it, but you will see in a bit that it will actually work. So what we can do now is in this null, we'll do out vel. All right, now if we go back up to our .NET, we can create a volume source. And so each of these inputs here have various things that you can do. And here we can do pre-solve. Sorry, no. We're going to do it here in the volume velocity, because we have a volume and it has velocity on it. So now we just go to the SOP path up here, do out vel, and then we're going to do this here. First, field rank, we have a vector, and then source volume is just V. Target field, since we're in DOPS, it looks for vel instead of V, so its target field is vel. And then there's nothing else that we really need to do there. And so just as a quick aside, what I'm doing here with this flip object is I'm bringing in a volume. And so input type, we have surface SOP. We can change it to things like narrowband. When I first tried to do this, I tried to actually create a narrowband flip sim here. However, one of the things that we need to do for this effect is we need to have it so that the volume maintains its point count, and narrowband relies on reseeding, and we can't have reseeding because that'll change the point count. And actually that reminds me that we need to go into the flip solver, and up here where it says particle motion, we're going to go to this tab here, reseeding, and we're going to turn it off because we want to maintain a consistent point count. It's very important for the next thing that we're going to do. Alright, so now we have our volume source. It's fed in here. I'm going to save just in case something goes wrong. And I'm going to make sure that the flipbook's good. Okay, so now I'm going to flipbook and we'll see if this is doing what it should be doing. Alright, the flipbook is good to go. So let's just give this a quick watch. And look at that. It is swirling our water. And I think that looks pretty cool. It's using sprites right now to represent the water particles, so it's looking a little chunky, but if we convert this to a VDB, I think it'll look totally fine. So this is exactly what we're wanting, and we're using that volume. Even though we couldn't see anything represented in the volume, it is clearly doing what it needs to be doing. So I'm going to close this out, and I think it's time to just write it out. But one of the things that we need to do before we do that is that we need to say, hey, don't spit out everything, just give us the points, because right now there's also the collision object, and so if we just were to write it out as is, it would give us the points and all this geo around it, and we don't want that. So one way to easily do that is we can just go in here and say, okay, these are the particles that we are affecting, so this is flip object 1. Just going to copy it, go back here, paste that, and now we just get the points. So now we're going to create a file cache. And for this effect, I think we only need about 60 frames. So I'm going to name this will just be our flip cache. And up here, just got to make sure that we don't have hip name. We're going to load from disk. And then here, for some reason, they have a default to report error, so that if there's ever missing frames, it kills anything below. So we're going to do no geometry, so that if this frame range gets past 60 frames, it doesn't just automatically destroy anything below it that's relying on this. Normally it should just think, oh, there's no frames? Okay, well I can keep going, but this is saying if this has no, or report error, it says, nope, you're done. Can't be doing any more simming. You got to figure out why it's missing frames. We don't want that, so we're going to do no geometry. So I'm going to hit go on this for the, oh yeah, I need to make sure that this is only 60 frames, so do 1060, and I'm going to hit go. So it's going to take a little bit for me and no time for you. So I'm hitting save to disk, boom.